Today we are going to do the third application of dimension analysis, and for me, and it's true that it is the most important application of dimension analysis. The first one was to correct the formula, to check the correctness of formula. Second one was to convert from one system to another. Now third, that is derivation of formula using dimensional analysis. We know many formulas, but with the help of dimensional analysis, we can derive formulas also. Let us see how. So there's a question over here. The time period of pendulum depends on mass of bob, length of string, and acceleration due to gravity. Derive formula of time period. So whenever a question comes like this for derivation, and in question it is given that time period is depending on few quantities, you have to think that it can be only done by dimensional analysis. Okay, you have to derive formula which depends on some quantities, mass, length, acceleration. There will be several questions in your notebook, in your books. So let us see how we have to do these questions. The first thing is that you have to give symbol to each and every quantity. For example, time period, I will use small t. For mass, I will use small m. For length, I will use small l. And for this, I will use small g. So time period depends on three quantities. It can be in 4, 5 in some questions, but the procedure won't change. Procedure will remain same. So the first is you give the symbol, that is t. So it is given that t depends mean sign of proportionality. Make sign of proportionality. Depends on mass, length, and small g. This is the first step. Now what you have to do, you have to give powers to all the quantities. If you have 3 quantities, give power ABC. If you have 4, ABCD, and 2, AB. So I'm giving power to M, that is A. I'm giving power to L, that is B. I'm giving power to small g, that is C. In next step, what we do, we take out proportionality sign, make it equal, and when a proportionality sign become equal, it becomes K. A constant comes there, that is K. So you're left with K, M to the power A, L to the power B, and small g to the power C. This is second step. First step is proportionality. Write down symbols on which it depends. Give power A, B, C, D, and so on. Depends on how many quantities are there. Second step is proportionality into equal, then K constant, M, A, B, and C. This is your first equation. Give this name to this equation. Let this equation be first. Easy. Now, what you have to do, you have to convert, after this step, you have to convert each and every quantity into its dimensions. Now, dimension of time is t. So make the bracket of dimension, write t. Okay, equal to constant does not have dimensions. Like example, half mv square we did in last video. Half does not have any dimension. Constant does not have any dimension. M to the power A, mass, dimension of mass is M. So M to the power A. Length dimension is L only. So L to the power B. This is acceleration. Dimension of acceleration is LT minus 2. So LT minus 2 to the power C. So what I have done in this step, I have converted every quantity into dimension, its dimension, dimension. Correct? Now, what you have to do, you have to make dimension in one bracket only. For example, here we don't have any m, so power of m is 0. We don't have any l, power is 0. We have only t, so this is LHS of this equation. Now if you see here, make only one bracket. You have to take every quantity in single bracket, that is m. Start with m, power of m is a, right? Power of m is a. I don't have any other m over here. Okay. Done. L, we'll start with L. Power of L is b, and there is one more L, which power is c. So it becomes b plus c. So are you getting what I'm doing? I'm bringing every dimension in single power, single digit. Now t, we don't have any t here, we don't have any t here, we have t here. Power is minus 2 into c, that is minus 2c. So after doing this, half the job is done. We have finished half the job. Now you just have to compare. You have to just compare. Let us compare. If you compare, it is m to the power a. Here is 0. So if you compare, what you get, a is equal to 0. Again compare, b plus c is equal to 0. b plus c is equal to 0. Again, minus 2c is equal to 1. So on comparing, you get these values. Now you have to solve these values to find value of a, b, and c. Now it might be tricky in some questions, but you have to do. Either you can do simultaneous equations. You have to use mathematical tools. You just have to find, these are 3 equations and you have to solve. You have to find the missing these variables. You have to find a, b, c. So it is a pretty easy question. A equals to 0. You have got one value. If you solve this, you will get value of c. What is the value of c? If you solve this, you get c is equal to minus half. Now if you put this value in this equation, what you get? If you put the value of minus half in here, what you get? B minus c equal to 0. B minus half equal to 0. So b is equal to plus half. So now you have all the values. You have all the values. You have a, you have b, you have c. The main aim is to find the value of a, b, and c. Now you just have to put these values in the first equation here, and you will get your formula. So let us put the value. We'll put the value here. T is equal to k to the power m to the power 0. M to the power 0. L to the power b, and b is half. L to the power half, and last is g to the power c, and g is minus half. Now you would just make it in a good way. Something to the power 0 is 1, so m will be eliminated from here. L half, g minus half. When this g comes in denominator, power becomes positive, and half, it becomes whole half. So you can write k L g to the power whole half. Now what do you mean by power of half? It means square root. So you can write t is equal to k under root L upon g. So this is the formula of time period. How I have done? I have solved by using dimension analysis, and this is your third application, that how you can derive formula using dimensional analysis.